Hi everyone, I'm Pranav Chachra. I'm a Principal Product Manager at AWS, and I have Lay, who's a Senior Director at Norton LifeLock, and Deepu, who's a CTO at Baptist Health, South Florida, joining us as well. And I'm really excited to talk about local zones, particularly because I've seen the journey of local zones where I started working on them 4 years back. I led the launch of first local zones in LA from product management perspective. And since then, I've been more focused on what services we want to bring to local zones and where do we want to take them as well. As part of the session today, we'll cover what local zones are, why we build them, where are these local zones available as well. And then finally, we'll get into what is the developer experience and how you can use these local zones as well. And then we'll bring Lay and Deepu who will talk about how to use these local zones, particularly for distributed applications, where you can distribute applications to multiple locations across the globe, and also to talk about hybrid cloud migrations as well. And then finally, I'll cover the data migration and data residency requirements use case, and we'll keep some time for the Q&A as well. So before I jump into what local zones are, let's discuss the cloud continuum. If you look at the cloud continuum, we have a lot of infrastructure types and services to support you and bring AWS wherever customers need us. We have AWS regions in 30 locations. We've also announced regions in 5 more countries as well. And then we have different edge offerings, including local zones, wavelength, and Outpost as well. Outpost is a fully managed service that extends AWS into virtually any data center and on-premises facilities that you want. It provides a truly consistent hybrid experience for you to bring your applications to places you want and have the low latency and also meet the data residency requirements as well. However, not every customer wants to maintain their own data centers, and that's where local zones come into picture, where local zones bring compute and storage closer to you and your end users without the need to procure, maintain, or manage your own hardware as well. On the other hand, wavelength is embedded into the 5G network, where the idea is that we want to bring ultra-low latency application experience to 5G devices. And all of these offerings provide the same consistent experience that you're used to in regions. We'll obviously discuss Snow Family and IoT in other sessions, so I'll skip it for now, and we'll jump into what local zones are. I think a key construct for us to understand what local zones are is what services are available in local zones as well. Overall, we support a number of services. When we started thinking about what services we want to bring to local zones, the idea was, let's focus on services where latency matters. And that's where we brought core services like Amazon EC2, Amazon EBS, Amazon EKS, ECS, and VPC, which are available in all local zones. And then we realized that a lot of these local zones are in different metro areas where they're industry hubs and they have different requirements. And that's where we started bringing certain services to certain locations. For example, GameLift, Application Load Balancer, EMR, RDS, FSX, and also Elastic Cache, which are available in select locations. The overall idea is that we want to bring services which our customers need in different locations. So you'll keep seeing the services increase, and also you'll see these services going to more locations as well over time. And that's beyond local services which are supported in local zones. There are other tools that work perfectly in local zones, just like how you use those tools in AZs. For example, all the API calls are logged via CloudTrail. You can continue to use familiar and powerful tools like CloudFormation, identity and access management, and auto-scaling, just like how you use them in regions as well. And then you can also use services like DynamoDB, S3, and others back in the parent region, given local zones are connected to our region using our own backbone, which is fully redundant. You can continue to use those services just like how you do today. So now that you've understood what local zones are and which services are available in local zones, I think the next logical question is, why did we even launch them? Before we get there, if you look at the overall footprint of AWS, we have the largest global footprint with 30 regions and 96 availability zones. And each of these availability zones are one or more data centers, and also over 410 point of presence as well. So the question is, why did we launch local zones despite having 30 regions across the globe? And the answer lies in developers' expectations. What developers told us was that they have significant number of applications that they want to run in AWS Cloud, and vast majority of these applications perform well in regions. However, for some of the latency-sensitive workloads and also workloads where residency matters, customers wanted us to be in more places, and that's where local zones came into picture. These workloads, which now customers have a choice to operate in local zones, traditionally required them to manage, operate, and also maintain their own IT infrastructure, which typically adds cost and operational complexity as well. The other thing that we heard from customers was that when they were using these, their own on-premises facilities, they had to build and run these applications components with a different set of APIs and tools, which they are not using in AWS regions otherwise. So to understand how local zones work, you can look at this queue. Let's assume that we have a customer or maybe their end user in the Houston metro area. In this case, if they have to use a region which is the closest one is the Northern Virginia region, the latency depends on where the end user is and also where the region is and the network path that traverses between the two. In this case, when we have 4 regions across the US, the latency is in the tens of milliseconds across the contiguous US. And that's when we launched local zones. We were able to reduce this latency across the contiguous US to single-digit millisecond latency. So in this case, now an end user who is sitting in Houston can access the resource in the Houston local zone. And given the network path traversing between the end user and the local zone, which is locally available, is shorter, the latency is lower and predictable. And I think that's how we're able to achieve low latency in this case. So the next question, which typically comes to the mind is, once we know what local zones do and what service is available, where are these local zones? If you look at this global map, we started with first local zones in LA in 2019. And then since then, we've expanded the presence into 16 metro areas across the US. And we're not stopping there. Based on the feedback we heard from customers globally and also the success we saw in the US, we are globally expanding the presence of local zones. So we've launched 8 local zones internationally, with 4 going live yesterday in places like Helsinki, Muscat, Copenhagen, and Argentina as well. And the idea is that these additional local zones that will come up live in the next year or so will be able to provide single-digit millisecond latency experience, not just in the US, but also internationally as well. So now that you've understood what local zones are and where they are, we can look into how they actually work in practice as well. So to get started, you first need to enable local zones. You can do that from the EC2 console or through the API as well. And once the local zones are enabled, they look and behave similarly to availability zones. So you can extend your existing VPC by creating a subnet and assigning it to the local zone. And once the VPC is created and you have the subnet, you can launch resources into the subnet just like how you do it for AZs as well. So if you look at this is how you will enable the local zone. You go to the EC2 console, you go to the zone settings page, and you look at the local zones which are part of the parent region, and you click on the manage access and you enable it, and it's ready within a couple of seconds. Once the local zone is enabled, they look and behave very similar to availability zones. So here you can see AP South 1, Del 1A, which is the local zone in Delhi, showing up alongside other AZs in the region, where AP South 1 tells you the parent region, and then Del tells you that it is an extension of the parent region, and the local zone physically lies in the Delhi metro area. Let's look at some of the concepts in the APIs and the CLI as well. You can see this when you call the API describe availability zones. You can see the local zone that has been enabled for your account. So the AP South1 del1A, which is the local zone name, can be passed into other APIs like create subnet, just like how you do it for other AZs. You can also see there is something called as network border group, where it's AP South1 del1, which is basically used to allocate IP addresses that can be used for EC2 instances in the local zone. And then applications built on local zone start with the VPC, just like how they do it in regions as well. Once the local zone is enabled, you can create a subnet, you can link it to the local zone, and once you assign it to the local zone, your VPC gets extended to the local zone, and you can start using this subnet. So in this screen, you see that I've already created a VPC subnet, and now that I have the VPC subnet, I can go and launch an EC2 instance in the Delhi metro area by using the subnet that we just created for the Delhi local zones. And similarly, you can also launch EBS volume types by selecting the zone, just like any other AZ. And once you launch resources, they're ready within a couple of seconds. You can manage these resources in local zones, similar to how you do it in regions. So in this case, the instance that we launched, AP South1 in AP South1 del1A is already live. So the important piece, I think, which we'll get into more details, is why and how are customers using these local zones as well. And that's where Lei and Deepu will come and talk about how they're actually using these local zones in practice. But before that, I want to basically talk about the broader category of use cases that we are seeing. If you look at this screen, there are two broader categories. One which is driven by latency, where customers are trying to drive down latency to their end users or to their corporate assets. And the other one is driven by regulatory reasons, where customers are trying to meet their data residency requirements in particular areas. And as part of the latency bucket, we've seen two broader subcategories, where there are customers who are using local zones in multiple locations across the US or globally as well, where customers like Norton LifeLock, Dish, or Supercell, they're using these local zones to reduce latency to their end users. And that's what we call as distributed edge as well. And then there are customers like Baptist Health, Netflix, and Mindbody, who are using local zones in specific locations where they are creating a hybrid architecture, or they're doing a hybrid migration, where the intent is that they want to reduce the latency between their corporate assets. It could be an office, it could be an animation hub, or it could be their own data center as well, to the local zone. And once they do that, the local zone looks like an extension of their corporate assets, and they can migrate applications incrementally. They can operate in a hybrid environment as well. So that sort of captures the first two categories. And then the regulatory, which is a broader category in itself, is where we are seeing a lot of customers who have specific data residency requirements like FanDuel or Rush Street using these local zones to meet their stringent data residency requirements either in states or even in countries as well. So we'll jump into the first category, which is where I'll invite Lei, who's a senior director at Norton LifeLock, to come and talk about how they're using local zones across the US and driving down the latency to their end users. Sorry.
Thank you. So a little bit about the company I work for. So I work for Norton LifeLock, the largest cyber safety consumer protection company in the world. The product we build is Norton Secure VPN. It's part of our Norton 360 suite. And also, you actually can get it as a standalone product. We have tens of millions of customers, millions of daily active users, thousands of edge servers deployed across the globe. And we have about petabytes of data transferred through AWS network. So let me talk a little bit more about why actually we want to migrate to AWS. Before we migrate to AWS, we deploy our solutions on third-party hosting providers. And here is a typical picture. We lease a really powerful bare metal server. And this kind of servers come with a fixed size bandwidth, like a gigabits for free, right? So it's basically all you can eat model, it's not metered. Then we virtualize the bare metal server and put 8 or 16 VPN servers on those things, right? So it sounds really great, right? So we have 8 or 16 servers. This is a really powerful box. However, there's an issue with this model because all these 8 servers, they're competing for this 1 gigabits bandwidth, right? So talk about, each server is only get 128 megabits of bandwidth, give or take a few, right? Depends on how busy your neighbors are. And also, this type of deployment also is a single point failure, right? So when the bare metal server dies, instead of only taking out 1 edge server, now you're taking out 8 or 16, right? Then what that means is the rest of the server have to pick up the slack, and which can easily lead to cascading failures. So that's not a great model, and this is the kind of experience users sees. It's pretty slow, pretty crowded, right? Eventually your traffic will get there, but it's gonna take a lot of time. Not only your customer would have a very poor experience. Here's what our engineering team feels like at 9 o'clock in the morning and doing our stand-up time. And the reason why we're falling asleep is because we've been dealing with production issues at 2 o'clock in the morning and 5 o'clock in the morning. Because when the server dies, we have to really spring into action, really try to fix it, because not only it's not 1 server, it's 8 server, it's 16 server, right? If we don't take care of it, the entire data center will go offline. So those are the 2 major reasons we actually want to migrate to AWS. So why is AWS better? Here's the deployment picture. When we move to AWS, each of the VPN edge servers now has about 750 megabits per second in terms of baseline network capability, right? We're actually running on C5 large, right? If you go to a larger instances, you get more bandwidth. So with this deployment, we increase our bandwidth limit by 6 times already, right? But even more important is the vast number of content providers and peered networks that AWS has, which allows AWS to route traffic effectively and optimally to its destination. Remember, we're building a VPN server, right? A VPN server is sitting in the middle. You have client talking to our servers. Then we have to forward the traffic to its eventual destination, right? So we might have great latencies going from the client to our VPN server. But that's not where traffic ends, right? They have to go all the way to the end. This is where AWS is really, really great because it actually allows us to route the traffic very, very optimally. And here is the user experience. I hope you're not expecting first class, right? But it's a lot faster, and it's still crowded, right? But eventually you will get there and in relative comfort. And here's our engineering team. Everybody's happy because we don't have to deal with outages anymore, right? Even if a server dies in the middle of the night, guess what? We always overbuild our capacity anyway. We can actually come in and deal with in the morning, right? Because it's 1 server, not 8 or 16. So I just want to show you one chart, right? Here's the growth after we migrate to AWS, right? So I don't even bother to show the chart before that, just because everything stays flat. This line here is the increase in monthly active users. And the second line here shows the increase in daily active users. And third line, it shows the growth in the amount of data we actually use, right? So what this chart tells us is when we provide user with a better experience, they come back, right? User use our stuff more. They use our stuff more on a daily basis. And at the same time, we actually reduce the cost by about 20% because we actually did a great job at negotiating our contract with AWS. And what I'm now showing here is the sharp drop in terms of support costs. We used to get support calls all the time saying, hey, I cannot connect, your stuff's so slow, your stuff sucks, right? And once we migrate to AWS, we get like the support costs dropped about 80%. So why do we actually look at local zones, right? Everything's going great, right? So after the migration, we're going back and look at what do our customers really care about, right? They care about latency. Latency to the edge. There are two latencies here in terms of the application we're building. Two latencies. One is latency to the edge, and then the latency to the content providers. The initial connection time. Obviously, upload-download speed. The shortest and quickest path to enter AWS network. Remember I talked about how AWS network provides such an edge in terms of all the other traffics, right? So as soon as you get into AWS network, the entire path, you travel through AWS backbones versus going through the internet hub all this time, right? For this purpose, we actually want to route customer traffic, enter into AWS network as soon as possible. And then here's some of the reviewers, what they care about. Pretty much the same thing. But one important thing here is they do care about the number of regions, right? So when we finish migration, we migrate from 14 probably cities down to 4, right? We actually get dinged on this. Now with local zones, we actually can bring our scores back up again. So why local zones are a perfect solution for us? So obviously, we want to place edge server closer to customers, shortest and quickest path to AWS network. We only require compute and network only, right? This is actually a perfect solution for us. We do not require any serverless solutions or anything that's really complicated, right? This is actually perfect. And the other things I think I really want to point out is by adapting local zones or some other solutions, all the telemetries and loggings work as if today, right? We already have the support. We have monitoring dashboard. We have alert setup, right? To support local zones, it's really easy, right? We have our infrastructure as a code. We just run it, builds up, stand it up, everything goes, right? This is another reason you actually want to look at local zones. So what goes into local zones? Our edge servers, end user stats collector, and traffic redirectors. Traffic redirector is something we build that the client will talk to first, and then we'll tell them, hey, here's the edge server you need to talk to, right? You want to respond fast as you can. What goes into our regional zones is going to be serverless, microservices, right? Managed services, data stores, analytic ingestions, et cetera. Okay, lessons learned. So you do want to automate local zone creation configurations, right? As more and more local zones come online, right? You do not want to do this by hand. And I'll tell you why in a little bit. You want to plan your subnet ranges carefully. Don't run out of IP addresses. And leave some room for future growth. So when Pranav announced all those wonderful local zones, right, in South America, he forgot to mention that which parent region those local zones actually belong to. Anybody take a guess? Want to take a guess? US East 1, right? And now, which region has the most local zones attached to it, US East 1, right? So as much as I'm really excited about all those new local zones, guess what? At this moment, we already run out of IP addresses, right? We can't even think about supporting all those local zones, right? So all this, our perfect plan, right, which we spent months, crafting and account for every single city in North America, just gone out the window, right? So maybe we'll do a little more like real-time planning. Pranav, do you mind to come up here, come on stage? Any more surprises that you want to tell us?
No, there are no surprises. I think you know by now which zones are launching and where the parent regions are.
You sure? Maybe another continent,
Maybe Antarctica, I've heard the penguins may need local zones there.
There you go. So, thank you. So you really have to plan for the unexpected, right? And then when something like that happens, when you have, internet crazy penguins, right? You gotta have a plan. So for us, it's actually pretty straightforward, right? So what we need to do is we need to go back to our IT folks and saying, hey, we're sorry, we're wrong, right? We did not plan for this, and we'll blame the penguins, and then we'll beg for more IP addresses, right? Once you have that, and then we can just easily attach them to the VPCs, then voila, ready. We have local zones support ready to go. Anybody enjoy getting paged on a Friday night? Anyone? No? If you don't, make sure you check for bugs related to region count. Okay? So obviously we did not do that. Not only that, we actually have a Jenkins job running that automatically deploy to production our infrastructure as code anytime any developer check in their changes, right? So what happens is on a Friday afternoon, this developer, I'm rolling out the new tagging libraries. Well, what harm can it be, right? Checking in, and our Jenkins job runs. And then pretty shortly after, we started getting paged and saying our VPN servers are offline for US East 1, right? And we have to scramble, we have to log in. Turns out half our network infrastructure has been destroyed. And the reason was we hard-coded a number of regions in the US to be 4. And the day before, we enabled local zones by hand, right? Remember I said, don't do this by hand. We enabled by hand, and when the job runs, it detects, oh, there's a new region, right? The infrastructure as code freaked out. And I start deleting all network resources for US East 1. So then we have to scramble, we have to redo everything by hand. And that did not make a very pleasant Friday night. So definitely do not do that. Definitely check the bug for that. Well, that's just only for configuration. Let's go into deployment. I think the theme, expecting the unexpected, continues for deployment. Just don't expect your local zone experience to be smooth, okay? If you expect for example, we use C5 large. If you expect C5 large to be every single local zones, don't count on that. They won't be there, right? If you expect your instances is going to be up after 2 seconds when you launch it, well, that's not going to happen, right? So you really have to be flexible. You really have to account for all these different situations, right? And if I want to launch 100 instances tomorrow, guess what? That's not going to work, right? So you really have to work with AWS account team, tell them, hey, I'm going to need 100 EC2 instances tomorrow in Miami, right? And you need to work with them. They need to do their planning as well, right? So this is not the same. This is not the same experience as what you have in the parent zones. And be patient and work with the support. And if we do all that, here is the reward, right? So we actually, once we launch, we see about 50% or better latency improvement. And in terms of, we reduce sometimes in some use cases up to 90% of the distance the customer had to travel before it hit VPN server. And but overall, see about 20% improvement in download speed. I think that is it for me. Thank you.
Thanks, Will. All right, so we've covered the distributed edge category. We'll get to the second one, which is also an important use case. I spoke about it a bit earlier. This is the hybrid deployment or hybrid migration use case, where enterprises like Netflix, Mindbody, or BHSF are establishing a hybrid environment between the local zone that provides ultra-low latency communication to their own corporate assets, including offices, animation hubs, or their data centers. In turn, this enables customers to migrate applications incrementally, which simplifies their migrations and helps them think about this as an ongoing hybrid deployment. As part of this category, I'll invite Deepu, who's the CTO at BHSF, to talk about how they are using local zones in Miami for this use case. Thanks, Deepu.
Hello, everybody. Thank you for having me here. I guess some of you at least may be surprised. Why is a guy from a healthcare institution doing here? So at the end of this discussion, at least I intend to clarify that for you. Before we get started on to the use cases for local zones, I'd like to spend a few minutes throwing light on who we are. Baptist Health, oh, by the way, if you don't know, there are probably 10 healthcare organizations by the same name. So we are Baptist Health South Florida. BHSF is the largest regional not-for-profit healthcare organization. We have around 12 now, 12 hospitals and 100 plus outpatient centers. We see around 1.5 million patients every year. We are going through a digital transformation like every other healthcare institution, and that's where cloud plays a strategic role. When we started our digital transformation / technology transformation journey around 16 months before, we realized to execute on the roadmap at the agility and the scale that we expect, cloud was one of the strategic imperatives. So we put the reference architecture on cloud and defined the RA and started migration. As of now, we disposed of our main data center and moved around 60% of applications to cloud. And we established a cloud-first deployment model since then. As we were going through the migration, we were encountering two categories of applications that we were having challenges to move. One is essentially applications that are poorly architected, I should say, which are chatty in nature and cannot tolerate even the slightest of latency, right? The second category essentially is those applications that are, don't quote me, using antiquated technology stack, so to speak. So as part of our RA, we defined a technical stack. Each app needs to be in so-and-so currency so that we can move the apps. So those two categories of applications created problems for us in the migrations, which forced us to deploy them into our own data centers. And as we looked at the two categories, the first category, which is applications that cannot tolerate latency, was the bigger pool. Vast majority of the applications that we had to retain fall into that category. And that's essentially where local zones come into picture. We use Miami local zone. Between the US East, which is our primary region, we see around 37 to 40 millisecond latency, where in Miami, we see around 2 milliseconds. So the application workloads that we had to retain because of that chattiness and low latency requirements could be moved into local zones. The setup from our perspective is not very different than what Pranav outlined in terms of, so we do have our direct connect via an exchange using the direct connect gateway paired with transit gateway for our main regions. For the local zones, we use the virtual private gateway. I believe transit gateway is in the roadmap for local zones, not yet available. So we use the virtual private gateway paired with the direct connect to extend the VPCs into the local zones. By now, you understood the benefits, the consistency with respect to the tools, processes, deployment processes. You don't have to have bifurcated deployment models between applications, low latency. We are able to move the applications that we had to retain because of those latency needs into cloud, agility in terms of migration, and consistency with respect to our security footprint. I'm not going to talk through all of these applications, but I will touch upon a couple. As this is healthcare, a lot of information is needed for physicians, for example, to assess a patient's condition, right? So the application on the top is essentially an application that collects information from the patients for assessing brain function. So that the amount of data is around 80 terabytes, and it's over a period of months. The data is collected over a period of months. And the physician uses a play function to go through and assess, okay, if there are anomalies in the brain function. So they can go up to 20x speed, so that to go through the entire set of 2-3 months of data, they have to play at that speed to be able to assess, okay, if there are anomalies. If there is latency, that could take up to 15 hours if it's not fast enough. So with local zones, we were able to bring down the latency to 2 milliseconds, and the speed of that entire processing came down to 30 minutes, under 30 minutes. And some of the other use cases are similar with respect to heavy image processing, where the physicians don't have to spend a lot of time churning in the information back and forth, and it speeds up the diagnosis and helps the patients that way. Pretty much most of the services that are available today, we are consuming from the local zones. It's not very different in terms of the service offerings that Pranav mentioned. I guess that sums up.
Thanks, Deepu.
Thank you.
So now that we have covered distributed edge and hybrid migration use case, we'll talk about the data residency or the regulatory-based use cases, where as a customer, you may operate in geos where regulations dictate where the data and the infrastructure reside. You may be a business that is working public sector entities where contracts specify where applications are deployed, or your enterprise may be in the process of migrating to the cloud, but as of yet, you haven't been able to use regions because of information security or other reasons. In these situations, customers can use local zones to ensure data remains within the geopolitical boundaries using services like Amazon EC2, Amazon EBS, and other locally available services. One thing to note here is that in order to ensure that your unique residency requirements are met, we do recommend that you work closely with your compliance and security teams to make sure that local zones and services address your use cases. One of the good examples for this particular category is FanDuel, where they had to rapidly expand to approved locations in the US while adhering to strict residency regulations. And what they did was they migrated their OpenStack and VMware platforms to local zones, where they were able to offload day-to-day infrastructure and let their engineers focus on delighting their own customers. What we've seen with FanDuel and also with other similar customers is that with the migration to local zones where they're able to meet residency requirements, the overall productivity obviously improves. They have been able to reduce the time to market as well, where they don't have to manage the capacity, they don't have to think about the scaling as well, with obviously other benefits, including reduced latency and also reduce operational overload. So one of the other questions that we hear from customers is, how should I think about higher availability with local zones as well? And the overall idea is that local zones can help you achieve higher availability while it helps you meet residency or latency requirements. There are multiple options for customers where, as a first option, customer can partition their workloads between the local zone and an availability zone back in the parent region, just like how they partition their applications between two AZs in the region. They can also think about partitioning their applications between the local zone and another local zone within the same metro if it's available, for example, in LA or in a nearby metro where they can think about Dallas or Houston that are together, or Philadelphia and New York, and similarly other local zones that are close by. And then if both of these options on the left side, including regions and local zones, don't work for you, we've seen customers thinking about partitioning their application between the local zone and an outpost, and also between their own on-premises data center as well. Overall, there are multiple options that exist here, and you should obviously work with the specialist or your partners to figure out which option can help you achieve higher availability here. With that, as always, we're listening to the feedback. We're working on bringing more services and bringing these local zones to more locations as well. If you are an AWS customer with low latency needs or residency needs, we obviously invite you to go and check out these local zones.